So today we will start Compton effect. We can कहथिले कि Compton effect ऐसे the whole process is actually to show the particle nature of light by scattering X-ray high energy radiation of free electron. Free electron नो X-ray scatter करवाले ये experiment ता design करा जाइए आउ इटा particle aspect of radiation के prove करती तो इथी क्या करने experiment we take a lead block actually lead block गुटे नैसो why we are taking lead block because in lead block the electrons are very loosely bounded to atom so that for radiation for incident radiation like X-ray high energy radiation the electrons behave like free electrons to it electron free electron way behave करते so what we actually observe in this experiment that when we incident a light of wavelength lambda or frequency nu we get the scattered wavelength of light lambda dash that is a bit more shifted than lambda lambda ro basic shifted the shift in wavelength is del lambda called as Compton shift in wavelength or there will be a shift in frequency nu dash which is less than nu lambda dash will be greater than lambda and nu dash will be less than nu the incident wavelength of light. So to explain this experiment we'll try to approach in classical electrodynamics by using classical electrodynamics that's the classical theory so according to classical theory जदि का हेता जदि गुटे रेडिएशन टे एक्स-रे रेडिएशन टे लीड ब्लॉक फ्री इलेक्ट्रॉन ने पड़ी देता तो it would have provided an oscillating electric field to the electron so that the due to the oscillating electric field the electron would have oscillated in oscillatory motion as a result of which as we know in classical electrodynamics that an oscillating electric charge radiates गुटे oscillating electric charge radiate करछि तो से oscillate करता इलेक्ट्रॉन टा due to the electric field provided by the incident X-ray or it would have emitted radiation and this theory tells that this emitted radiation by the oscillating electron has the same wavelength as the applied wavelength incident wavelength but the intensity of the emitted radiation from this oscillating electron is proportional to the applied intensity of the light X-ray but in experiment we are observing a shift in wavelength lambda dash not lambda classical theory tells us that we'll be getting a wavelength of the order of lambda same as the applied wavelength of light but in experiment we are observing a shift in wavelength del lambda dash equal lambda plus del lambda so we can conclude that classical theory or classical electrodynamics could not explain Compton effect. So now we have to apply quantum approach or quantum mechanical nature of light, that is the particle nature of light. So as we know, according to particle nature of light, we can quantize light energy E is equal to nh nu with the frequency of the light. So here suppose this is the free electron. The whole process we are approaching like the elastic collision between two particles, one is photon and one is free electron. So this is the suppose this is the scenario before collision and this is the scenario after collision. This is so what happens before collision? X-ray photon h nu of energy h nu frequency nu or let it be momentum magnitude h nu by c is the magnitude of the momentum. This is the free electron having rest mass me. So before collision only the photon has energy h nu, it has rest mass energy how much? According to Einstein it has rest mass energy me c square. This has momentum p is equal to h nu by c in this direction. After collision what is the scenario? The electrons get recoiled in this direction with an momentum pe and the photon gets scattered in this direction with an angle of scattering theta. This is the initial direction of the approaching photon before collision. So this after collision this photon momentum of the scattered photon make an angle theta with the incident direction of the X-ray. So it is theta. this has momentum p dash is equal to h nu dash by c, or energy h nu dash. Nu dash is the frequency of the scattered photon. In the same way, p dash is the momentum of the scattered photon, h nu dash by c. This is after collision scenario. So we'll as you solve for a elastic collision problem in classical mechanics, we will solve like that, the moment by applying the principle of conservation of momentum and then applying the principle of conservation of energy. So first we will apply principle of conservation of momentum. So momentum before collision, momentum after collision should be equal as a universal law. Is applied to any kind of physics. Whether you study about quantum mechanics, whether you study about relativistic quantum mechanics, whether you study about quantum electrodynamics, or whether you study about quantum chromodynamics, in each and every field of physics you can apply momentum conservation principle and energy conservation principle. Unlike the action is equal to reaction, action is equal to reaction, then third law of Newton cannot be applied in any field of physics. Like in relativity you cannot apply action is equal to reaction law. Okay, तो p initial momentum photon रा खाली थिला, इलेक्ट्रॉन रा रेस्ट थिला, so इधर momentum 0, momentum electron is 0, momentum of photon is p vector. We are representing vector equation. So momentum of the scattered photon is p dash, momentum of the recoiled electron is, let it be p with an subscript e, p. So p is equal to p minus p dash vector, p vector minus p dash vector. Or as we get the magnitude of two resultant vector, making in theta, if a and b are two vector and theta is the angle between them, then the resultant vector has magnitude f is equal to a square plus b square minus 2ab cos theta, result from vector addition. Vector addition answer enta asi. So applying this in this case, p square is equal to p square plus p dash square minus 2 p dash cos theta. Theta is the angle between p and p dash. Here this is the theta. This was the initial direction of p. This is the initial direction of photon. This is the final direction of photon after scattering. So this is the angle theta. This serves as the true vector p and p dash vector. So now we will apply the energy conservation principle. I am marking this equation 1. It will be useful later to solve these equations of energy conservation. So in energy conservation, energy before collision is this. H nu is the energy of the photon, and as the electron is at rest, now it has some rest mass energy, m is c square. This is the rest mass energy of the electron. Now the photon gets scattered as observed by experiment, so it has some new energy, h nu dash. Nu dash is the shift frequency. Later we will convert it into wavelength form. And this is the energy of the electron in motion. It's come from the Einstein energy momentum relation. E square is equal to p square c square plus m0 square c4, or E is equal to p square c square plus m0 square c4. No, Einstein relation da. So here p is the momentum of the electron, p square c square plus m square c4. This is the energy of the recoiled electron. This is the energy of the scattered photon. This is the energy of the rest electron. This is the energy of the incident photon. Now we'll try to solve it. So this is the relation we are getting. Now we are putting the value of p square from the previous momentum conservation relation, that p square plus p dash square minus 2 p dash cos theta into c square. This is the p square value. This is multiplied by c square, m square c4. This is the energy before collision, energy after collision. Now we are putting the magnitude value p square, means we have to now put the magnitude of each value p dash. So p ର magnitude केते h nu by c ना कहितली, and therefore it is h nu square by c square. P square is equal to h nu square by c square. P dash ta h square nu square dash h square nu dash square by c square, or 2 h square nu dash square cos theta. Putting the value of multiplied by c square, p square, c square. The each term has c square in its denominator, so we can cancel out with this c square, multiply in the numerator. c square cancel कर देना, तो बचा खुचा टर्म कण एच न्यू स्क्वायर लेफ्ट हैंड तो से प्राय सेम अच्छे ये एच न्यू डैश एक्चुअली लेफ्ट हैंड साइड के आनी पकाले एच न्यू माइनस एच न्यू डैश दिस इज लेफ्ट हैंड साइड के आनी पकाले है एच न्यू माइनस एच न्यू डैश प्लस एम सी स्क्वायर एच न्यू माइनस एम सी स्क्वायर राइट हैंड साइड एतकी है तो नाउ वी वांट टू गेट रिड ऑफ द स्क्वायर रूट टर्म ये स्क्वायर रूट टर्म हटावार ले चाहूँ तो क्या करमा विल स्क्वायर बोथ साइड टेक स्क्वायर ऑफ बोथ साइड तो ये टोटल टर्म स्क्वायर ना पहले ये एच टर्म कैंसिल कर दें फर्स्ट वी वांट टू कैंसिल द एच टर्म बोथ साइड सो मैं क्या करी एच कमन नहीं ली सो न्यू माइनस न्यू डैश बचला एच कमन एम सी स्क्वायर पे एच बचला इे भी एच कमन नहीं स्क्वायर अच्छे फिर रूट ओवर अच्छे बेला एच बाहर के आसले खाली एच रहा न्यू स्क्वायर प्लस न्यू डैश स्क्वायर माइनस 2 न्यू डैश cos एम स्क्वायर सी 4 by एच स्क्वायर आसला नाउ वी वांट टू गेट रिड ऑफ द स्क्वायर रूट टर्म सो आई एम टेकिंग स्क्वायर ऑन बोथ साइड सो न्यू माइनस न्यू डैश स्क्वायर न्यू माइनस न्यू डैश प्लस एम सी स्क्वायर बाय एच होल स्क्वायर इज इक्वल टू न्यू स्क्वायर प्लस न्यू डैश स्क्वायर माइनस 2 न्यू डैश cos एम स्क्वायर सी 4 by एच स्क्वायर है एदिके बुझलु तापरे इच टर्म रो स्क्वायर नवा ए प्लस बी होल स्क्वायर ना ए स्क्वायर प्लस बी स्क्वायर प्लस 2ab तो न्यू माइनस न्यू डैश रो स्क्वायर प्लस एम स्क्वायर सी 4 by एच स्क्वायर प्लस न्यू माइनस न्यू डैश एम सी स्क्वायर by एच ए स्क्वायर प्लस बी स्क्वायर प्लस 2ab काडे हेंता स्क्वायर कर देछुं बोले खाली इटा बचे न्यू स्क्वायर प्लस न्यू डैश का माइनस 2 न्यू डैश cos एम स्क्वायर सी 4 by एच that we have both side m square c 4 by h square so we are cancelling this term बचला केते न्यू माइनस न्यू डैश होल स्क्वायर प्लस 2 न्यू माइनस न्यू डैश एम सी स्क्वायर बाय एच इज इक्वल टू न्यू स्क्वायर प्लस न्यू डैश स्क्वायर माइनस 2 न्यू डैश cos इधर फिर स्क्वायर केते हबा न्यू स्क्वायर प्लस न्यू डैश स्क्वायर माइनस 2 न्यू डैश प्लस 2 न्यू माइनस न्यू दिस टर्म इज द सेम एतकी सेम है तो same as this तापरे we have both side new square and new dash square as well so we can cancel out this so बचला केते 2 new minus new dash m square this I am taking right hand side so 2 new new dash minus 2 new dash cos theta 2 cancel out both sides 2 so new minus new dash m square by h dash 1 minus cos theta न्यू माइनस न्यू डैश इज इक्वल टू एच टा याड गला न्यू डैश एम सी स्क्वायर एच टा याड पलाला एम सी स्क्वायर तलके पलाला ना cos थीटा तो न्यू डैश आई एम टेकिंग टू दिस साइड डिवाइडिंग both new and dividing with both new and new dash separately मतलब बचला केते h by m c square 1 minus cos थीटा इन न्यू कटला मतलब 1 by new dash इन न्यू डैश कटला 1 by न्यू इज इक्वल टू h by m c स्क्वायर 1 minus cos थीटा न्यूटा c by लैम्डा डैश न्यू डैश टा आइटा c by लैम्डा ऊपर गला इन लैम्डा ऊपर गला c will cancel out with this or I can take c this to the numerator of this side right hand side तो c कटला तो h c गुटे कटला तो लैम्डा डैश माइनस लैम्डा इज इक्वल टू हैला h by m c 1 minus cos थीटा दिस इज द shifting wavelength तो lambda dash केते हेबा lambda dash ता therefore lambda dash is equal lambda plus this shifting wavelength h by m c 1 minus cos theta है तो मैक्सिमम केते हेबा एतल थीटा इज इक्वल टू थीटा इज इक्वल टू 90 degree cos theta is equal to 0 so lambda dash is equal this is also called h by m c also called as Compton wavelength lambda c noted by term lambda c तो lambda dash is equal to lambda plus h by m c when theta is equal to 90 degree lambda dash will be maximum shift will be in the wavelength of light जतले theta ta scattering when the scattering angle is 90 degree then lambda dash shift in the wavelength will be maximum हां तो here for a particular x-ray lambda is constant and as we know mass of electron rest mass of electron is constant also light is constant so the shifted wavelength is solely dependent on the scattering angle of the photon theta so this is all about Compton effect this also proves well the particle nature of light this also gives and strong experimental evidence of the particle nature of light and this phenomena can only be explained by taking the quantum nature of light or discrete nature of light. It cannot be explained by taking light as an electromagnetic wave. That's all about Compton effect.